with a single entity anywhere. So when we are going to book the product, then only we will deal with the product, but that too will fetch it from the list. We get the list from the database of hundreds of laptops, and the customer has selected one laptop out of those 100, and then he wants to buy it. Then over there also we are dealing with the list, right? Even though it would be from the front end and those dealings, and front end also needs to deal with the list that we are going to send the list. So now the thing is, in the collection, every time we work, we have to work with a group or list. We can call it list also, but group is a better terminology. So we have to deal with groups everywhere, whatever we want to do. Even with a single bank account also, if you'll see, if I want to see the history of transaction that I did, so that is also a grouped thing, right? It can be grouped as uh, the credited amount and or the debited amount, and then it will have a complete list that okay, this much amount has been debited and this much amount has been credited. So whatever we are writing, we have to work with collections or the groups. So to handle those things, so every language maker knows this thing that okay, we have to work with the anyone who's going to use our language have to work with the groups, and to handle the groups we need data structures to work with it, right? And these data structures are used for temporary basis. This array we are not going to save, in most cases we are not going to save the array completely into the database. No SQL database are there where we can do it directly, but in most cases we are not going to save these things. We never save a stack, right? Because we'll make a stack, use it, and then that's it. If I have a stack of student, it's not like it's going to be saved as a stack. It's going to save as students only, but I will keep it in a stack if my purpose is of LIFO or FIFO. A stack is LIFO, last in first out. So if my purpose is to work with the students in case of LIFO, as LIFO, then I will use stack, right? But I'm not going to save it in the database as stack. It will be saved as a single row per student. It's not going to be saved as a stack. I just want to hold that data for a limited amount of time and then process it and then leave it, right? I will directly save it into the database. Some data structures, some data is saved as the data structure suggests, but not entirely. That's our some limited thing, and that too to make sure that data we get the data in faster manner in the databases. You will see the indexes is also in the B tree, right? B tree is also data structure. So that side, so we know that to handle the data we need data structures. So to work with the data structures, now the language, whoever is creating the language, then they have two things. One thing is they can let the people write the data structure on their own, one thing, but it increases the complexity because not everyone is able to write the code in the best manner, right? The first thing is to provide the language so that the beginner can also use it. Yeah? Beginner user friendly language is required in today's era. That's why Python is doing so much great. And so for this, every language provides some basic data structures so that even a fresher or even the college grad who's not too much involved into the data structures or the algos, he or she can also work with it. So that's why the collections. You will see the collection of the similar framework in every language, right? In every major language which is used in the production level and accepted by the industry, be it C++, C Sharp, Java, Python, Ruby on Rails, Groovy, everywhere Rust. You will see something like the collection. They might say it something else. For list, they say list will become something else over there. Set will become something else over there. But the basic logic will remain same. So over here, and then the thing is, the basic array that we were saying over here, we will leave it. We are not going to move ahead with this thing because this thing we are going to cover it in the later as well for every data structure almost. So every collection classes almost. So there, okay, so there is these interfaces are there in the collection. We will going to see this a lot of times. Comparable, comparator, again important, iterator, then entry, and these things. And let me make some notes as well. Okay, not required. I can work with, please leave, and I can work with this only, and over here I can leave a class, and okay. So now if I have a group, right, for example this is a group, and let's say these are share prices, right, share price. This is share prices on a particular day, and then these share prices can be, let's suppose, let's mimic PNB share price. It has been 101, 100, and mostly 98, 96. Today on it's going on 95. All right, so this is a share price, right? Now the thing is, this is a group also, right? I can have it as an array, or I can have it as a collections if I'm, and the similar thing in other languages. So the thing is, what operations can I do over here, right? Again, DSA. One thing I want to fetch data from it, right? I want to traverse it, right? I need to traverse it, and I will move from here and here, right? So then I can search it. For search, traverse is required, right? If I want to know that whether 98 is here or not, I have to traverse it, right? Then what else I can do? I can do the sorting. Right now it's in the descending order, but what if I want the data in the ascending order? I can sort it also, right? Then later on, with the Java 8 version, filtering, conversion is also conversion. Okay, conversion version. Okay, all right, cool. I'm not remembering. Okay, cool. What's the spelling of conversion? Cool. Now great, cool. So that's it. So these two has also added in the later version, and we can do a lot of stuff in the Java 8. So these are the three things that we can do. If we have any data structure, we can traverse, we can search in the data structure, we can traverse in the data structure, and we can sort the data structure, sort the data into inside the data structure. And that thing we do with data structures, right? Whether be it array, be it tree, be it heap, again a part of tree also, only be it stack, queue, right, linked list. We can traverse these data structures, we can search in these data structures. Obviously we need to traverse, and then we can sort these data structures. Again, sorting also traverse is required, right? So traverse is the most important thing. Then for filtering is search only, then leaving other things out. And then the conversion is like, if I have integer, then I can convert it into long. If I have a student, I can convert it into teacher. I have a list of student I want to get out. I want a set of class teachers of those student. So there might be 40 students, but only 2 class teachers, right? Section A and B. So that's what conversion is. So for these three, these are the things that we are going to do for every data structure that we are going, every collection class that we will see. And but to traverse, search, sort, filter, or convert thing from one data structure, we want data structures, right? So they already have three: list, set, and map. Anyone having any idea regarding these three? All right, I'm audible.
Yeah.
All right, cool. So list will have array list, linked list. These are data structures also, and these are classes also. List is the interface, and these are implementation classes. We are going to see this in a while. And then there is a stack, there is vector. We are not going to cover these two. It's again way too basic, right? And then set, the implementation classes are hash set, linked hash set, and tree set, right? And the map, hash map, linked hash map, and tree map. All right, so these are the classes, right? But these classes will provide us these features, right? So they must have some data structure also, right? All the classes are shouting, right? on its own, like okay, array list, right? Its data structure, underlying data structure must be array. Linked list, right? It's the name of the data structure itself. Stack, name of the data structure itself, right? Vector, I must be thinking of 12 class vector thing, right? Then set you must have read on the discrete mathematics class. In a set there is no duplicates, right? Okay, those who never done the discrete maths, no worry, we will cover it also. And the map is a specialized data structure which use hash table, so hash over here, and it usually have data in key value pair, string and string. And the example of it can be, one string can be country like India, and another string can be Delhi, its state. Give me just 1 minute, I'll come.
Yeah.
Alright, so where were we? Okay, no, please. Okay, oh, alright. So this is key and this is value. If I want to get some data from the key India, we'll get the value Delhi. So it's the key value structure. You will find it entire NoSQL is basically based on key value, especially the document based DB. So I mean, okay, we can leave the document based DB, but for the cache solutions like the Redis, it's also a NoSQL database. Over there also you will see the same thing. Terminal. Okay, I need to start it first. How many of you have worked with Redis? How many of you know the key value pair thing, how it works? Okay. See, in this thing, this Redis, ActiveMQ, no, ActiveMQ is Q, Redis, Aerospike, and Hazelcast. In Q systems, AWS, SQS, ActiveMQ, Kafka. Even service-based people also know about these things nowadays. So everyone needs to know about these things, right? See, this is a key, right? I want to get data, which data they have saved with this key. So this is the data, this is a JSON. Alright, so this must be some product ID. Okay, this is amount in INR. Currency is INR. L, I don't know what it is. B can be the total amount, something. So this was the key and this is the value, right? And this is some conversion, currency conversion rate, and this is the key again, and I can get the value something. This is the some percentage of AED and INR, right? So these you will find the hash table and hash map everywhere. Not a single system is being in the working state without the key value pair and without the Q solutions in today's era. Alright, so let's leave this. So now we are left with these three main parent interfaces. Over here if we'll see, these are interfaces, right? Key interfaces, list, set, right? Then this sorted set, navigable set, these all are set, right? Q is also interface, map, sorted map, navigable map. We'll see what is this. Iterator is, right? List, iterator, comparator, comparable. So over here, let's come back over here. So for traverse, we have for loop for each loop, and we have iterator, and we have list iterator. We have now streams to traverse. These are the things we have for traversing. Which one can be used with which collection, we'll see in later session. For search, obviously we need to traverse for search, so we have to use only this thing, right? Then for the sorting, okay, some provide some basic methods, but school will, it's not of that much weightage. Now the sorting, for sorting we have comparable and comparator. We will see this, what these things are. Then filtering and sorting we can do manually also, but these are mainly part of the streams where, okay, first level and second level functions are used. First level, second level functions, we are not, okay, let's leave, this is not in our course. This is functional programming things, so we'll see some basic streams only. Alright, But you can go and read about first level and second level functions nowadays, because every language is mostly moving towards the function, so one needs to know. And then monads design patterns is also there. You can read that also, right? Because these are based on first level and second level functions along with the monad design pattern. So if you want to go through it, you have the recording, you have this thing, and you can go and read and learn about this on your own. All right, so where were we? All right, so let's start doing this thing, right? So every we have, I mean, it's not the pure data structure, right? So we have a lot of functions written on it. So we must know how they have implemented it, how they have implemented the array list, how they have implemented the linked list, how they have implemented the stack. Now the very okay, let's okay. So the very basic question that's not going to be asked for from a experienced person is, what is array versus linked list, array list versus linked list, when to use which one, right? Very 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 basic question, right? But the thing is, for to answer this thing, you don't need to know the Java. You can just simply tell that when to use array and when to use linked list. If you know the difference between these two, then you're completely good to go. When to use hash set, when to use tree set. So over here you need to know underlying structures, that how, which tree is it, right? AVL tree, red black tree, which tree is it's going to be used inside it, B tree, N tree, which tree is being used, and what operation, what add-on it's being provided, because we have sorted set and navigable set also with it. So what these two annotations do, these two interfaces do, so we need to know about it all. Stack, obviously, when to use stack, when to use linked list, these are the data structures. So if you're good with the data structure, that's why some companies hire directly if people are good with the DSA, because they can learn it very easily, the rest of the things, if they know this. So all right, we'll cover this thing also over here also in a jiffy. And all right, so now everything is clear till now. These are the things that we are going to cover from here. This is the collections in a nutshell. I'm audible?
Yeah.
All right, so let's start with the list. So the difference between array and collection, it's very underrated item. Let's cover and then we'll see. Okay, so these are, I mean, if you know the array data structures, then it's become way too easy. It will be in fixed in size, right? These three we have already covered. So array will always be fixed in size, right? If you know the internal implementation of it, we go and get a fixed memory, right? And then we start working on it. So if we want more memory, then we'll go and take more data, more space, and then we can work with it. That's what we do with the arrays. But now now as a primitive data structures, we have only one thing, array, to work with, right? But with the collection, we have linked list also, right? With collection framework, we have linked list also. Okay, we have linked list also, this linked list. All right, so we can use this, so we don't need contiguous memory allocation. So the drawback of array is there, right? So okay, with memory error, okay, again, why arrays are not recommended to use, because if you want only one, if you want to use and save only a price of a share in a single minute or a single day, and let's suppose we might in our operation, we might want the data of a particular share for entire month. So what can happen, we entire month, let's say that a month is of 31 days, so 4 byte into 31, right? Because we are taking as an integer, so 4 byte into 31 will be the amount that we might use. But for the array, if you are using an array, the might use does not matter, right? It will going to consume 31 into 4 bytes. So that's the drawback. With the linked list, we can use, of course we have multiple options over here to use, so we have one of those are linked list in the collection. So we have a flexibility to go with the linked list. And again, as you all know, that linked list, in the linked list, it's we are not confined with the contiguous memory allocation, because we have links between the memory chunks. So if you know the size, okay, also the thing is, if you don't know the total size that you require in an array, that we cannot use the array. Very 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 important thing to know. And over here, if you don't know, then it's completely cool, because every structure that we use over here, even The array list have a internal global array, and we have discussed how the global array worked in the last session. Okay. Okay, so okay, cool. So it does not define any predefined method, right? It's a primitive data type. So if you want to sort it, you need to write the sorting algorithm on your own. But in the collections, you can sort the data structure without writing or knowing any sorting algorithms, because we have two things to work with if you want to sort. One thing is comparable and the second thing is comparator. We will see what's the difference between these two, which to use when. So while working with the array, add remove operations are become difficult and it's not supporting in the methods. We have to write all these things right on our own. But over here, all methods are provided. So it become way too easy to use with the collection, and that's why we use on a daily basis. Not a single, okay, sometimes we have to create our own data structures, but those data structures are specific to the company requirement and the policy. And we just made it just to make sure that the performance becomes a little better. Otherwise, it's a very rare chance that some people are creating the data structures on their own in a language to work with. All right. So now these are the characteristics of all collection classes, which are the collection interfaces or the classes you can say, and with other collection classes. These list, set, map. This each one of them, not this much, apart from the an entry also. If you leave three, this map, this set, and this list, these three will have some characteristics, over 8 characteristics, and which will be in which version it is introduced does not matter in nowadays. You can leave it. Whether the heterogeneous data is allowed or not. We have already discussed the heterogeneous data in the last session, right? Heterogeneous data is this one, right? If I want to create an array, I cannot save multiple data in the array of different data types, right? Because if I create an array of integer and suppose it's the stock prices, now I am forced to create only the stock prices over here, right? So one thing is, if I directly have the stock prices, I can directly put over here, right? Now I have created it. And if I don't have this thing, the prices, then I have to first mention that okay, 2 stock prices I need to save, and then the stock price, and my bad, and 0 and then 1, and let's suppose the second one is 2. This is how I can initialize the array. Now the thing is, can I save over here boolean true, right? No, it will provide an error, right? Int required, and we have provided true. So the array does not work with heterogeneous data, but collection do, right? Collection only works, okay, collection can work with heterogeneous data and it works with only object. But what if I use object array, new object array, and over here if I put array 0 equals to 1, and then array 1, okay, I need to put the size, and then boolean dot true. All right, now it can work, right? And then I can traverse over it also. Okay, object value, and then object, my bad, array. So over here I can sys out the value, but the thing is, it's object, right? Object class, so the value will not be printed directly, because object class toString method provides class name at the rate hex, right, of hash code. So if I run this, it will just provide the classes. Oh, okay, cool. Why we get this thing, the values? Am I audible?
Yeah.
Why we get the values? Due to override. This boolean dot true, boolean inside has this toString, right? And the toString is printing the value, visible value over here. Same goes with integer, and why it's 1 over here, right? But it's been converted into integer class by autoboxing, right? Now the integer class also prints the value. So to string value value bool. All right. But the thing is, these classes has the toString, but if I want to use it, now the thing, now the bad thing is, I have to use an instance of if value instance of integer, then only print, else not print. All right. So now the boolean true will not be visible over here if I run this. It's not visible, right? Because the second one, array1 value, which was boolean, is not a instance of integer, right? Instance of is a keyword that we need to, because due to the overriding the object, the reference variable is of the parent class, right? Like this one, this reference variable is of parent class, right? But if I want to know which child class it supports, so I can use the instance of variable for this. So in this manner, I have to write code again and again if I use this object array as well, right? And this is a drawback. This is not something that we can work around with collections also. In the collections also, this is an issue. If I use the heterogeneous data, then this is an issue that we need to check the instance of. We need to use the instance of operator multiple times, and that's why we will never use in the real time scenario, in the production environment, we never use heterogeneous collection. We always make it homogeneous. And how we make a collection homogeneous? Right now it's working, right? But if I say that I want a list of students, so I will make it a student list. So now these all things will give me an error, because I mentioned that list is boolean cannot be converted into student, right? I am trying to add boolean over here. So that's how we restrict our collection to work as a homogeneous data structure. Diamond operator under this is called generics. All right, clear till now? Am I audible? Hello.
Yeah.
Yeah,
All right. So this example is just in the case if someone asks you, then nobody's going to ask you, okay, is it possible for us by not using any collection, then to store, if you want to store homogeneous or heterogeneous data, can we store it? So yes, we can store it, right? This thing we have already seen, right? It's the same thing with the array. All right. But yes, without the object we cannot use it, right? With the primitive data structures we cannot use it. With the objects we can use it, right? Object class can be, because the object class is the parent class of all Java objects, so it can store, the array of object class can store the heterogeneous data. So but nobody is going to ask you this thing, but if someone does, then this is the answer, and this is the code that you can write. All right, so let's move, and now let's see these things, right? We are going to see all these things. So the very first thing is when the collection was introduced, but not important. Another thing, whether the heterogeneous data allowed or not. Heterogeneous data is different data that we can put it, right? So you can each collection implementation class provides you or supports the heterogeneous data. But the thing is, tree set and tree map, these are two things that don't provide heterogeneous data, or anything with a tree does not provide heterogeneous data support. They only supports the homogeneous data, and the reason is they auto sort things. Whatever data you send it, they will try to sort it. So if you try to enter a 1 and then boolean, how will they sort it, right? We cannot sort integer with boolean, or a student object with a teacher object, right? So for sorting we require homogeneous data. This is the very first thing. Without the homogeneous data we cannot sort, right? If someone provides you an array which can have the, I mean, array can be of object array, right? Object class array with integer, and then integer long, if it's of number, child class is of number class, then it's fine. But if it's not the child class of number class, and it has the character string and then boolean also, then we won't be able to sort it, right? So that's the thing. That's why these thing, whichever collections try to auto sort things, they cannot support heterogeneous data, right? They need homogeneous data to make sure that they are able to sort. Now the another thing is with these collections that whether they allow the null or not, right? Again, if I want to sort thing, right? If I want to sort thing, and let's suppose if I say that okay, my set, it's a set, right? Even it's mentioned tree, but it's a set. If I want to keep a set and it will be automatically sorted, so if I enter, let's suppose it's a set of city names in India. So let's suppose just one city name I entered is Delhi, right? And another city name I entered is Ahmedabad, right? So it will be automatically sorted and Ahmedabad will be at the top. And then if I try to enter the null object, right? So how can I sort null, right? With the strings. So some classes supports the sorting of null objects and some don't support the null insertions. So we need to know which one supports null insertion and which does not support null insertion, and why we need to know this thing. Let's suppose I am trying to fetch data from the database, and I am trying to fetch a particular column data, and that column is not nullable. Column is nullable, right? Everyone is aware of database, right? In the database some columns can be null and some columns cannot be null. I'm audible?
Yeah.
Yeah,
All right.
yeah,
Okay, okay, Kishore, I know you know. So, all right. So the thing is, if I try to fetch the data from that database, and the column has the nullable values also, right? So what will happen? And I will try to convert that data from the database into a list, and the list can contain null, right? Then there will be a null pointer exception in our code. So that's why we need to and we should use only those collections if we're trying to fetch data from the database which can have the null object. And this is just a single example, right? Single real life example. There are many more. So we need to know, that's why we need to know whether they allow the null insertion or not, right? So, and then let's go for the duplicates also. See, some allow duplicates and some don't allow duplicates. Again, why we need to do it, right? Again, if I have a list of students whose marks I want to know, right? Or if I have a lot of requests in my server and then I'm unable to respond to all of them, then I will keep it in queue. And if I have those requests in a queue, then what I can do with the queue is I can pre-process those things, right? And what's about pre-processing? I can remove some request. How can I remove some request? Because if some parents multiple times want the same report, then I don't have to entertain this request again and again, right? I can just send the report at a single one time if the request is same. Like for example, if you want your bank don't do it but it should do it. Like if you want your transaction report from X date to Y date, and you click 3 times for the report, right? Obviously bank, you will get a notification because these operations are heavy. You will get the notification that okay, in a few minutes of time you will get the report in your email, right? The reason for this operation is these operations are heavy, so it requires time. So they store these requests into the queue, and then later on when the servers have time, they keep on processing it and you get your mails. This is how it works internally. But the thing is, if you are getting multiple requests of the same user, then they don't allow, right? Circuit breaker design pattern, I think you must have heard of it, right? Why I'm saying these things, that our session is going to complete in 2 to 3 days, so these are the things that you must know. So in the circuit breaker is okay, not goes in the circuit breaker, but the thing is, in the queue, if we have 10 requests, or in the array if we have the 10 requests, we can process that array and find out the duplicate ones, right? And we can remove those duplicate requests. And what will be the benefit if we are able to remove the request, right? Duplicate request. The thing is, each request involves database connection and then fetching data from the database. And if the same user gets 3 mails, right? Every time it gets 3 mails. I mean, if we enter 10,000 times, so that queue will have requests from him 10,000 times. And what will he do with the 10,000 emails of the same data? And in the same time, other people were waiting and they have to wait for hours to get their report. So by removing this thing, by making sure that we are not entertaining the duplicate request, we can use the sets, and it's not a single thing, right? We can use it in multiple manners also. Like we have the uh, distinct keyword in our database where we can get distinct values in our column. Like for example, the types of products that the company sold. It can be the electronics, wearables, I mean clothing, electronics, kitchenware, right? So I just want to know these things. So I can directly write a query like, okay, select distinct and then inside this product type from the products table. And this is how I can get this only 4 rows, right? But if someone is not a good developer, at least not a good SQL writer, and he gets all the product lists and then he wants to remove the duplicates from it, so he can use the set for it. That's why, okay, I mean, set has this thing of not having any duplicates, so it can use they can use the set data structures to remove it, right? So duplicates, some collections allow the duplicates and some don't allow the duplicates, right? Some might throw exceptions if we try to duplicate things, some will just ignore the request of adding the duplicate data. We will see those things again. Another thing is insertion order. Let's suppose if I entered one, I mean I have a request from user 1, then user 2, and then user 3, right? And if request comes in the same sequence, then should I show the data also in the same sequence, or should I process the data into the same sequence? So that's with the insertion order. In the queue it's also okay. Let's not go into the queue services. So insertion order is again important, right? So if I have a list of operation that I want to do in a number, like for example, if I have an operation, why insertion order is important, I'm just trying to display this, because let's suppose we have a equals to b, a equals to 10, and b equals to 20. Okay, my bad. int equals to 10. Okay, is already defined. Let's say int k and k l and then dm klm. So if these are the three, okay, let's change it. Let's say make it 5 and let's make it 2. So I have two requests. One request is add k. One request is do k plus l, and other request is okay and l plus m, l into m. And let's say that okay, whenever I perform any operation, the right one demolishes and only left one stays, right? For example, if I do the k plus 1, so what I'll only k will survive, right? L will collapse. In this only l into m, only l will survive, l will survive, right? So in this case what will happen, k and m will survive, right? In the array, in the numbers, k and m will survive, and in this k and again okay, no, over here k and m will survive, right? So now if I want to perform these operation, what will happen? Now the sequence matter, right? If I do the k plus 1 first, and then whatever is left, I will divide it. Those two numbers I will divide by whichever is left. So what will happen if I do this thing and then this thing? The value will be different, right? Because it's mathematical operations. So sequencing matters in this mathematical operation. That's why we have the BODMAS, right? I'm audible?
Yeah.
So it's k plus l, it will be 15, right? And then 15, if I have to divide by 2, it will be 7.5, right? I'm audible?
Yeah. Yeah.
And over here, if I do l into m first, l into m, then it will be 10. Then if I'll do 10 divided by 10, it will be 1. So the answers are different. So it depends on the sequencing of operation that I'm doing. So it is very, again, it's important, the listing, right? Whether we want to preserve the order or not. And because if you are creating a racing system, right? So whichever entry comes first, that should be the winner, right? Not some random person. So that's the thing. So insertion order is also very important. Now whether the collection are synchronized and non-synchronized, see again it does not matter nowadays, because uh, we can have all the collections, synchronized version of all the collections we can get directly using a single class. But usually we don't do not use synchronized version of it, and we have synchronized, I mean we have some classes which supports the multi-threading way much better, like the concurrent hash map, write on read on write and write on array maps. We have arrays, we have multiple classes that support this. So what eventually happens is we don't care whether they are synchronized or non-synchronized, but we can go ahead and read about it. And the last part is underlying data structure. This is important. This is the thing that mostly in the interview people ask, and whether they support the cursors or not. And for this it's become way too easy. Two things are way too easy, right? Heterogeneous, whichever collections allow the auto sorting, it does not support heterogeneous data. And wherever you will see tree, just close your eyes and answer okay, it does not support heterogeneous data. Nobody is going to ask this question also, right? It's just for your personal knowledge nowadays. Earlier it is being used, asked. And over here also, this is also very easy to answer. Only list supports iterators. Okay, so these two answers are easy. Let's go and see the very first interface that we are going to do today. It's list interface. I'm audible?
Yeah.
So see over here, you will see the collection will be the parent interface of all the interfaces, right? There are three important interfaces: list, map. Okay, over here this is list mentioned, right? List, set, and map. So this is also an interface, and list is also an interface, right? Which whatever is annotated with C is a class, whatever is annotated with I is an interface. So the thing is, ArrayList is an implementation class, linked list is an implementation class, vector is also an implementation class, and stack is also an implementation class, right? Nowadays nobody asks the question in which version they exist, because it's Google is there, we can directly know about it. Earlier there was some issue, so that's why version was important to know. All right, and whichever is present from the version 1 is called the legacy. All right, legacy class. See over here it's also mentioned, right? Legacy class introduced in one version. So alright, so the list interface has four implementation classes: array list, linked list, vector, and stack. Right over here you can see. Alright, let's go and check it also. Okay, array list we have already opened. Cool. So basics, let's write the basics. Basics runner. Now psvm array. Okay, we can have the list parent class list, right? List equals to new array list. All right, so list equal to new array list. All right, so this is the implementation class. Let's see list interface, right? 1.2 version, interface list, right? Extends collection. That's what you are seeing it over here, right? Collections interface child class list, right? Over here extends. If the type is same, interface, we use extends. If the type is different, we use implements, right? We have already covered this. Inheritance. So over here list interface extend collection, right? And now let's go to array list. Now array list is a child class, right? So this child class will implement the list interface. Let's go inside it. This is the array list. Let's move at the top. Class array list extends abstracts list. Okay, this implements again list. Visible over here list. Audible? And
Yeah.
visible?
Yeah.
So alright, this is just a representation of what we can see using our ID also. So now we will see these data structures in with one by one the properties that we see over here, right? So in which version they was introduced, it does not matter nowadays, so we can skip this. Now the list allows, now these four are the most important things that we should know about all the data, all the collections classes. So we'll see these four things. So this is the array structures. Will it allow the heterogeneous data or not? Then let's see. Let list dot add 1, and then list dot add true, and then list dot add and 1.8, and list dot add, and then we can have any name. Let's suppose Dikshita, dictionary and then C. Y. Okay, now cool. Sys out and heterogeneous data and over here list. All right, if we run this, it will be able to print it, right? All the data heterogeneous 1 true 1.8 and etc, right? Visible. So it supports, right, heterogeneous data. So it supports heterogeneous data. So over here we can write support simple heterogeneous data or heterogeneous data allowed. Alright, so one thing we have marked that it's true. Heterogeneous data allowed with the array list. Okay, cool. Wait, one thing. See, okay. One thing we need to know, where's the diagram? See, one thing, I mean, there are few out of these 8 things that we need to know. Out of these 8 things that we need to know, there are few interfaces, right? There are list, there are set, there is map, right? They have certain, I mean, cause in the interface over here in the list interface, it forces you to implement some methods, right? That's what's for interfaces for, right? And the child classes needs to implement those methods. So some interfaces force their child class to implement certain methods. So every interface like list, set and map has some features spread across all their child classes, right? So every class, okay, so you will see over here characteristics of array list, right? But the thing is, you will see over here list interface common properties visible. I'm audible?
Yeah.
So these 4 properties is of list interface, right? So list interface has it. So parent has those properties. So already these behaviors or properties will be extended to their child, right? So all these array list, linked list, vector, stack will follow these 4 properties. Same goes with the sets. Like one single property of a set is it don't allow duplicate values. So whether it's head set, link set or tree set, it will not allow, all the child classes of set will not allow duplicate values. So same with the list. All child classes of the list can preserve the insertion order. All all child classes of list can will allow duplicates, and all child class of list will allow the insertion order, and all child class of list will allow you to save the heterogeneous data. All right, so these are the common properties. Out of these 8 properties, 4 properties are common in a list interface. In every interface almost 3 to 4 properties will be same. Let's move back and check the second property, that it allow null insertion, right? So why to write another code? So let's add over here null. All right, so if we run this again, so let's write one more thing, null insertion allowed, right? If we run this now, so null over here, right? So null insertion is already allowed. Property number 2 also we have checked. Now the third thing is insertion order is preserved or not, right? Over here we can see 1 we entered first, then true we entered second, then 1.8, then Dikshita, then null. So one can argue that how can you make sure, right? If I can change this thing and then run it again, now the null will be at the third number, right? So the insertion number is preserved, right? So insertion order is preserved. This is one again a more property. Again, now the thing is, fourth property that's common is it whether it's allowed to duplicate or not, right? So let's duplicate a value, right? Again, so right now if we see the Dikshita is printed twice, right? Because it allowed the duplicates. All right, okay, let me change this. Duplicates are allowed. Cool, visible.
Yeah.
Now the thing is, these are the common things, right? Whether it will be linked list, array list, does not matter. These properties will remain same. And then you can say, but why we believe you, right? So no worries, don't. We can have linked list basics. All right, and then we are not going to do anything. We'll just come here, copy paste this thing, right? And paste over here, right? So this is of array list, right now working. And let's run this, and you will find one true, null 1.8 Dikshita, right? Duplicates, null insertion, right? Heterogeneous data, and sequence preserved, right? I will just keep bill here and just change it with the linked list, right now I'm at the linked list. And if we run it again, same, everything is exactly same. Duplicates allowed, null insertion allowed, insertion of order preserved, and heterogeneous data, right? So we have done same thing with the linked list also, right? Same thing you can try and do it on your own with the stack and vector and check. All right, now the thing is, okay, the properties that are different. So with the array, again, very basic array, use the data structure array, all already know, but it will have some global array. Null allowed, duplicate allowed, these are common. We inserted data in the same way, okay, it will print it, cool. It's non-synchronized method, okay, every collection will have the non-synchronized method, right? If you want, then it will be created as a synchronized. And over here, see, this is the global array part, right? So the array list, it's shouting that it's going to use the array. So array list internally use global array, all right? And then whether it's support the cursor, yes, it supports the iterator and the list cursor, all right? So these two are for traversal, right? So now let's go and check and create a array. Right now we just printed the data, right? It's a toString of the list interface, right? That's how this data is printed. We are not traversing and printing it, right? So what I'm going to do, I'm just going to copy paste this thing of array list right now. Okay, basic runner of array list, and I'll just copy it with the heterogeneous data only. And we go to the traversing, and in the traversing I will, okay, we have to create again list interfaces, and then set, and then map in the list again array list iteration runner. So what I'm going to do is simply print this thing, right? But instead of doing sys out now, what I can do, okay, see, traversing is not just of iterator, right? So okay, let's use the iterator thing first, or or let's just remove this example. I'm going to create my array list on my own, and instead of this I will first show you all different types of ways in which I can traverse this. So okay, over here again I need to create packages, and by packages let's list array list, and inside list I have an array list, and then I can have linked list also. Whether I write code in that or not, it will depend. Now in the array list I can have, okay, in a single class I will show you, no worries. All right, so let's have a list, and then let's make it integer list only, right? I don't want any other heterogeneous data, I just want homogeneous data. So I want list and list of okay, values. Let's name this list values, right? No worries. And over here, not linked list, I want array list, and arrays as list, right? This is a short version of creating a list for, okay, new is not required. All right, so this will, if one thing that we were doing earlier was sys out and values, right? And it will provide the data, right? But it will use these brackets we don't put, right? This commas also we haven't used. So this is a toString of list class, right? If I go inside the list class and we'll check the toString method of it, we have nothing, right? Because this is the interface. But what we are using as list, but it's returning array list. And in the array list, if we go to the toString, it's appending the comma, right? Visible, it's appending the bracket. So we are using the child class, and which child class we are using? Array list right now. So this is the toString of the array list. So what we want to traverse, so we are not going to use this thing, right? So how can I traverse? One thing is, for int I equals to 0, like we were traversing array, right? I less than, and then values dot size. it will give the value of n, and then I plus plus, right? Sys out. And over here I can mention now that okay, sys out values dot get, and I can pass the index, get the 0th index value. It uses the array underlying data structure, right? So I can pass the index, like I can pass the index in the array. If it was integer array equals to new integer array and 1, 2 and 3, right? I can get the value, I can get the same value by array and 0, right? And the index can be anything 0. So this thing is exactly replica of this thing, and this thing, how I'm getting the value, this is replica of this thing, right? So now the thing is, if I try to run this now, okay, one more thing to do is sys out later. Okay, not required now. So this is a normal for loop. 1 1 1 1. Okay, my bad, I need to put I over here. All right, so let's run it again. Now we'll get 1 2 3 4, right? What we can do is simply add one comma also to make it little bit more readable, so that we know that okay, these are separate values. 1 2 3 4, right? And how I traversed it, I traverse it using traversal using for loop, okay, or legacy for loop also we call it. So this is the one of the ways, right? Traverse is using for loop. Now the thing is, I need to sys out first just to make sure next line happens, and then how I can traverse using, and now I can traverse using for each loop. This for each loop was introduced in Java version 5. So now see, the thing is, if I want to traverse, right, these values I want, if I want some control, right, if I want some control over traversing, right, 1 2 3 4, if I want to some skip these values, right, if I want to skip the index 2 and I want to directly go to 3, right, in that scenario this thing is good, right, because I want control over the indexes. But if I just want, simply I want to just traverse from one end to another end, right? So in that particular case, when I want to traverse from one end to another without skipping or without having any control of the array or list or anything that we are working with, so do I really need these values indexes? If I just want to traverse this thing, this array, then I know that this list is this array list of values is of integer, right, over here. So I know that it will provide me integer every time, right? So why to add integer over here? This is of index also, right? So why to have indexes, right? If I want to move from left to right, then why, and I want to traverse from here to there completely without making any changes, then why to keep an integer for the indexes, right? It does not make sense, and it's of array itself, right? So what I can, how we can write this thing is simply that okay, we have the values, right, and values will keep on passing the value, and which value it can pass, it's of integer array. So integer value it will keep on passing. So how it works, whenever you pass a collection, especially this collection list, so it will start, the pointer will be at the 1, and it will keep on moving ahead. As soon as it passed inside this value 1, the the pointer will increment at the very start. At the very start, the increment pointer will be here, and it will move at the right hand side, and as soon as one value is provided, the I value will increment, and it will internally, this indexes will be handled internally. You don't have to do it on your own. But the thing is, you don't have its access, so you cannot skip some values if you want to, right? We can do I plus 2 over here also, right? We can do okay, I equals to I plus 2, we can do this thing also, right? So it will print 1, and then instead of moving at the second value, it will move to the third value, right? 1 and 3 will be printed only. If I run this now, 1 and 3 will be printed only, right? Because I have plus twice, then the plus 2 value index, two values I have jumped from 1, it does not move to 2, I just move to 3. So that's what I can do it over here if I'm using the normal looping, the legacy for loop if I'm using. But with the for each loop I cannot do this, I have to traverse from left to right. The only thing I can do, I can break the values here. So if I'm already getting the values, so directly value plus and this and this. So this is also again the same thing. If I run this, traversing using for loop, this, traversing using for each loop, this, right? Okay, I can add a space over here just to make sure both return the same data. See, same, right? So this thing is for each loop and this thing is for loop. These are the two ways that we have seen we can traverse a collection. Third way is iterator, right? And then how we can use the iterators, you will get iterator. Iterator is an object and iterator is a design pattern also. GUF design pattern, if you know. Then okay, someone joined again. Hello, am I audible?
Yeah, yeah.
Yeah,
So
yeah.
now we are working with the iterators, right? So what's the iterator? So every, not every collection, but few collections or their implementation classes provides iterator. And we have already seen over here that common list interface properties is that it has the, okay, okay, it is not, it's not in the common, it's not in the common, all right, it's in the subclasses, right? Whether they want to provide it or not, but you will get it almost in every list interface, right? So over here what happens in this, again, this is a design pattern. In iterator is a design pattern. It is usually created, whatever happening over here in these two, that's thing, it will do it on its own as well. But there are few things to know with the iterators. First thing, iterator object is there, right? So if I want to traverse it, I will do whether the iterator has the next values. Again, if I see this 1 2 3 4, what happens over here is this is my array list, right, with the values 1 2 3 4. So the iterator will, when the iterator object is created, it will stand over here before this thing, right? And hash next will check whether the next value exists or not. So if the value, if the hash next is there, so it will return boolean true, that okay, next value exists in the list. So what will happen, we can simply go and print the value. And how can I get the value? Itr dot next. So as soon as I call the next, what next do is, it was before, wait, it was, oh my bad, it was before the first value, right? When I checked hash next, it checked whether I'm standing at -1, so at the 0th index it has the value, right? So this thing returns true. So I go inside that line number 33. Over here I'm checking whether give me the next value. So I have checked first, right? This is the way we write code with the iterators. First check whether next value exists using hash next, and then if you want to consume the value, then use next and it will provide you the value 1. But the thing is, it will increment the cursor as well, and the cursor will be at 1 value. So over here 1 will be printed, but I want com also, my bad, com also. So that's how I'm going to write it and remove the len. So now then in the next loop, it will check again, it's standing at the 0th position now, has next, it will check whether next value exists or not, right? So exists, so next will give us the 2 value and increment the cursor as well. Same thing will happen with 3 also. Check whether next value exists, yes, so give the next value, it will give the next value, increment the cursor and then give the value. And then again with the 4, same thing happen. And when I'm at the 4 and I've printed the 4 over here, then again we come to this iterator hash next value, and then we don't have any next value, so it will provide us the false. So the loop will end. So this is how the iterator works. So iterator, traversing using iterator, traversing using iterator. All right, so now if I run this code again, okay, I need to add one sys out more at the top. All right, let's run this again now. So see, this was using normal for loop, this was using for each loop, and this was using iterator. All right, let me add space as well. Now if I run this, we will see exact same, right? Now we need to see these two methods is good enough, but what are the other method, right? Hash code is there, right? And iterator has next, remove, we can remove the value also, right, from here. And this for each remaining, this thing has come in the version 1.8. If you go inside this was introduced in 1.8. We will see it later on because it's uses the consumer and all those things. This is in the streams part. Not going to cover what's the consumer and all those things is. You can read it on your own. If you are good with the Java, it will be way too easy for you to know it. And now, okay, other methods, right? It has very few methods, right? And one thing to know over here, see, now we know wait, notify, all these are of hash code equal, these are of object class methods, right? I'm audible?
Yeah, yes,
So
yes.
only next, hash next, remove, and this for each remaining is there, right? And for each remaining also moves in the right side. So you can see that there is no way to move backwards, right? Because there is only next, right? Over here there is no previous, right? So I can only move towards the right hand side. But if I want to move towards the left hand side also, so again now there is new thing also. All right, and it's list iterator. So how we get the iterator object, right? Again, it's a part of the iterator design pattern. Not going to discuss over here today in this session. So iterator design pattern says that the data structure that you are using, it will provide you the object of the iterable. So the values dot iterator, right? This is called, I mean, again, this thing what I'm telling you right now, this is not a part of the Java. These methods which provide us the object is called factory methods. Again, a design pattern, factory method. So this, and it's providing an object of different class, right? Not as, okay, cool, I'm not going, don't have to dive deep into this. So you will see that the child class, we are using the array list, so we can directly go, okay, we need to open the array list to see the implementation classes. Okay, we can directly go from here. Why to write again, right? So in the array list you can find the method iterator. All right, so it is returning you a array iterator object, right? And if you go here and check, so it's a static nested class, right? Arrays.java. So it's in the arrays.java and static class iterator. All right, so the iterator object, to provide the iterator object, the data structure is responsible to provide the iterator object. So it's a part of design pattern. You will eventually read it somewhere. It's a behavioral design pattern thing. So I just wanted to let you know that this thing, that a object, a data structure, or a implementation class of a list interface or a collection interface is providing an object of iterator. The reason is this is a design pattern, and that's how the things is being done. So if I want a list iterator, right, so it needs to be the same, right? The values will provide the list iterator, and over here everything will be same. I will just say call it list iterator, and over here list iterator. Nothing has changed, right? But why we need list iterator if we had the iterator already? So again, we will do the same thing, right? Whatever I have told about you regarding the iterator, same thing will work with the list iterator also. That with the list iterator, I will check first whether it has the next value. Then if it has the next value, so I want the value, I want the next, right? I get the value, and then I can just do this, right? And then if I run the code again, you can see, okay, ln I need to remove. So if I run this code again, you will see traversing using list iterator is also same, right? So why do they feel that they need to provide a list iterator while the iterator was already there in the legacy code 1.0 version? The thing is, over here, if you'll see, if I'll just simply do one thing, list iterator dot, now you will see has next, right? Remove. Now set, you have seen we can set the value, we can go previous also, has previous index, right? Indexes also we can get next index, previous index, we can set the value. In the iterator we can just remove the value, in the list iterator we can set the value also. And in the iterator we cannot move backwards, we can only move forward, but in the list iterator we can move backward also, right? I'm audible?
Yeah, yeah.
Yeah.
So that's the difference, and that's it for today. Okay, we can sort, okay, now let's sort later on. So we will in the, we'll have a session. Okay, today we had a short session, but the next session will be of 2 to 3 hour long.